Yes, we are live now.
Yeah.
Good evening, everyone. It is a great pleasure to welcome you all today for this eighth session in our Sky Watching series. I, Dr. Govind Lakhotia, on behalf of Professor Rajendra Singh Science Exploratory, welcomes you all. We are truly honored to have with us today an extraordinary personality whose work quite literally reaches the stars, Mr. Dorje Angchuk. Mr. Dorje Angchuk serves as an engineer in charge at Indian Astronomical Observatory, that is IOA, in Hanle, Ladakh, one of the highest astronomical observatories in the world. For nearly 3 decades, he has been at the forefront of maintaining and advancing sophisticated telescopes and scientific systems under some of the most challenging high altitude conditions on the Earth. Beyond his engineering excellence, he is also a celebrated astrophotographer. His remarkable images of the night sky have earned national recognition, including the Astronomical Society of India's Comet, that is Neowise Photography Award, and have been featured in international platforms such as the New Yorker. In 2018, he was honored as an honorary member of International Astronomical Union, becoming the only Indian to receive this distinction at that time. Mr. Angchuk has also played an important role in promoting astrotourism and preserving dark skies in India, particularly through his contributions to the Hanle Dark Sky Reserve. His work beautifully combines science, technology, and public outreach, inspiring countless minds to look up and explore the universe. Dear students, today you are not just attending a lecture, you are about to hear from someone who works every day under some of the clearest skies in the world, bringing us closer to the mysteries of the cosmos. Let us extend a warm welcome to Mr. Dorje Angchuk. May I now request Mr. Dorje Angchuk to start the session?
Um, Good evening, everyone, and thank you very much for inviting me here. It was a very short notice for me, and although my expertise is not very much into the dark sky object, but definitely I will try to enlighten whatever I know, and with the help of some of the resources that I manage from the Bangalore Astronomical Society. And I was actually running around for some personal works, and I just drove something 270 kilometers to Hanle just now for some work. Anyway, fine. I'll just let you know about some of the observing the deep sky objects, and also about the dark sky tips, and what we are lacking in terms of beautiful starry skies. So here, as a first image, you can see me under the beautiful night skies of Hanle, just near my observatory. And here you can see many different stars, and the stars with star color. For example, on the can you see my mouse? So just above me is the Sirius star, and then you can see the which is totally white, and you can see the Orion and with the Betelgeuse as yellow stars, and we have the Taurus and the Plates constellation. So different constellations. Beautiful, it inspires art. So as we know that this image was drawn by Van Gogh. It's widely hailed as his magnum opus, and he drew it while inside his sanitarium, and whatever the scene was from outside, and it was widely hailed. And as astronomy is enigmatic, it leads to science. And here you can see the observatory where I am stationed right now, and I've been working since last 28 years. And so this is beautiful. This is the image, and on the right you can see that is the Himalayan Chandra telescope. We have a 2 meter class telescope which works in the optical and infrared region. And this is a really professional observatory. Professional astronomers from all over India, through a time allocation committee, they get their schedule time to observe, and these are through a schedule mode. Uh, Through a time allocation committee, they get their night once in every month. So it is a very highly subscribed telescope, and it is one of the best working telescope all over India. And here you can, it leads to science. See, this is one of the very images of Crab Nebula that was taken from this telescope. Okay, and many of you might be sitting in cities where it is actually totally light polluted. The only thing that you can see over your head will be either some aeroplane passing, or the moon, or some bright planets. uh, but this is what we are lacking in the city, and that's what I wanted to emphasize also while telling you about the deep sky objects. And so this is what we are lacking. And if you are very lucky to come to a place like Hanley, then you will be, this is a single shot, you will be able to see the Milky Way, the summer Milky Way with the core. And you can see the Jupiter and Saturn, which are on the left side of the dome. So this is what we have, like our ancestors, they have been learning a lot from astronomy, be it the timekeeping, navigation, and also like we have learned many things looking into the skies. So, what is the night sky? So, typically, we have seen in the you must have seen a lot of like stars, planets, um, and a lot of yellowish glow light, which is called the light pollution. If you live in a city, and if you haven't seen the night sky, please, you can go outside and see if it's not cloudy, and see what you are able to see in the night sky. So what are the stars? As you might, because you are all interested in astronomy, you must have heard about the stars, which are like balls of hot gases. And because they are hot, they emit light. And they are all around in space. And our closest star is the sun, and the sun is a yellow star. And do you know that there are other stars which comes in different colors? There are red stars. Red stars are cooler than the other stars, and red shows the lower degree of hotness than the yellow stars. There are many bright red stars in the sky if you look up. And some of the examples are Mirak, Aldebaran, Hamal. These are like in summer you can see Antares in the Scorpio constellation. It's actually red star, and you can use star chart of software. There are a lot of software nowadays. You can like Stellarium, Sky Map, etc., which can be installed in the mobile, and you can use it. Um, so there are some blue stars which are among the hottest stars. And the blue star is usually not very conspicuous. Definitely, it is not as conspicuous as red. Or it's very prominent while looking through a telescope, or while imaging it through a DSLR telescope, or even electronic cameras. So some of the example, if you are in winter, it's the Regal Ashmer, and in summer, the blue star or the Spica. Must be the Spica is quite a bright star, and you can see it nowadays because it's March and it's just rising in the evening. And orange star, just a moment. Yung like about the orange stars are cooler stars. Okay, so there are some of example is the ultras, and there are white stars. So as I told you in the first image, the Sirius is the brightest star in the sky, and that is why it is visible in the winter in the northern hemisphere just after the Orion rises. And we define all the stars with the magnitude. So magnitude is scale which is used to compare the brightness of a star. So the larger the magnitude of an object, the fainter it is. For example, a magnitude of 3.5 star is fainter than a 2.5 star. And the magnitude is like the magnitude difference of one corresponds to 2.5 times in increase in brightness. And if it is if so if you multiply 2.5 times, so a magnitude difference of 5 corresponds to 100 times in the brightness. So our sun is the has the maximum, obviously, magnitude, so it's minus 27. Sirius, being the brightest star, is minus 1.4. Similarly, we have Vega and Arcturus at the zero point zero 0.01 and minus 0.04. So what else are there, other than the stars and the planets? There are a lot of many things that you can see as a deep sky object. So the aim of this presentation is to tell you what else is there and try to tell you how much more interesting this can get. So obviously there are groups of stars, and you can see there are double stars, asterism, open cluster, global cluster, galaxy. We will give some examples. So double star, there are very beautiful, when you look at the Ursa Major, the fifth, the sixth star is a double star. You can through a very dark sky places like Ladakh, we have seen, like, you can easily make out the double star and the two star, and it can be easily seen through a telescope, and that is a beautiful sight. And there are like there are many telescope like Aldebro, which can be seen through a telescope like a double star. And there, the beauty of Albiro is like one is a pair of different color star. One is a yellow and one is a blue star. And asterism is like when you just join together a few stars in line, then you get the asterism. For example, the Orion looks like a 37 joined together. You can use software to look at then, like open cluster. These are a group of stars. So but unlike asterism, these are very of a common origin. They have originated from a single gaseous hot gas and of nitrogen and helium. So open clusters, they form very nice and interesting patterns, but you can enjoy them best with a telescope. So binocular can also be used, and it's very nice. So one of the beautiful nice open cluster that we can see nowadays is the in the setting sky in the evening is the Blades M45. Then there's like many things like M35 butterfly cluster, and most of them you will need a telescope to see. So for example, this is one of the image of the Blades. It's a beautiful six star, and in Ladakh we call the Minduk. So that is the six sisters. Basically, if you see through visually, then you can see only six stars here. So there are a lot of global clusters. There are like thousands of stars lying close to each other. So, and they are very packed, closely packed. And some examples of global clusters are M13 Hercules, M22 Omega Centauri, M5, M3. And this is Omega Centauri. You can see they're closely packed. And galaxies, they're like large. They are large, obviously, just like we say the Milky Way is our home galaxy. We call the Milky Way galaxy. So similarly, you can also see a lot of galaxy. And as you know, our nearest galaxy is the Andromeda galaxy. And from a dark sky, you can easily see the Andromeda galaxy. And so a typical galaxy has 10 raised to power 7 to 10 raised to power 12 stars. So you can imagine how much stars will be there. And there are like billions of galaxies in the stars. So those galaxies themselves are of different types. You can say spiral bar, elliptical, irregular. And as the name suggests, they are spiral in shape. Then I will show you in the next example a pinwheel galaxy, which is situated in the Ursa Major. These are binocular objects. So and kindly note that we won't be able to see the different colors here. If you see through a binocular or a telescope, it will be just a black and white, because our eyes are very sensitive. It's not very sensitive. It cannot distinguish color in a night sky. Okay, so so you don't expect that it will be just a plain fuzzy patch. And how we are getting this much detail is that through a telescope we are stacking lots of data, and we are getting these images. uh, this detailed images. Otherwise, it will be just like a fuzzy plain page. A telescope with a 24-inch diameter mirror will show the spiral shape, but you cannot see any color, so don't expect. So there are many irregular galaxies which is irregular in shape. For example, the cigar galaxy, this is and it looks like a cigar galaxy. And what we can see is a galaxy. Galaxies like make out through small telescope. We can make out whether how it is, whether it is edge on or face on. We may be able to see the dark lanes in some galaxies. We may be able to make some peculiar features, just like spiral and elliptical. So this is one of the galaxies, and Sombero galaxy. Here you can see it's etched on, and also here you can see in between it's a uh, dark nebula in between. And this is a face on example of a face on M101 again. So face on spiral galaxy, and here you can see again the Sombara galaxy with the dark lane in the core. So basically, there are a lot of beautiful galaxies you can try: M31, M33, and M77. So a lot more you can see through this one. And gas nebula also. Gas nebulas are very interesting because one we can see because there are clouds of glowing gases. Obviously, there can be a case like where the stars are star formation region is going on. So gas nebula often appears very beautiful in photographs, but they are through telescope they are just like a fuzzy patch, fuzzy black and white clouds. So very few nebula are visible. So there are a lot of gas nebulas, but then only few prominent ones are visible through telescopes. For example, the when you see the core of the Great Orion Nebula, you can see it's totally fuzzy, black and white. So this is one of the example of gas nebula. So in so this is quite a lot of telescope are, beautiful images are there, and there it is designated as M20. There are other uh, uh, gas nebulas, like you can see there's the Eagle Nebula, which and you can see a lot of star formation region there. There's the Rosette Nebula, and so there are like many gas nebulas. The Obviously, with the coming of the summer, you can see the lagoon drift nebula, and obviously now the Great Orion Nebula is setting. So you can think, and also you can see a lot of supernova remnants. So supernova remnant is something like when the star it exhausts all the nuclear fuel, then the gravity it just uh, uh, pulls all the material, and then there is a sudden explosion, and this and it mm, happens like it becomes a supernova remnant. Then so it's the remains of the star which are ejected, and that remains glow due to high temperature. There are a lot of supernova remnant, and the prominent is the M1, so the Crab Nebula. So you must have heard about the Crab Nebula. Like this was one of the four supernova explosion that was recorded in our own galaxy, and this happened 1,000 years back when the Chinese astronomers they in 1054 they actually recorded that there was a big glow in the night sky. So so as I was mentioning, many etc. So what is the M designation? So M stands for Messier. It was like a French. He was a comet hunter and astronomer. His name was Charles Messier, and he catalogued many of the bright objects which were in the sky. And when he was so M1, the Crab Nebula was the I think when he done it was quite bright. So maybe probably that is why he started with M1 at that time. Now it's because it was a supernova remnant, so slowly it is losing its nebulosity and the lightness. So M1 was the first object in the, and there are like right now there are 110 deep sky objects, Messier objects, and it includes all the bright sky objects in the sky. So prominent among them is M45 and 31, you can see. So NGC stands for New General Catalog, and it was created by Dyer. And now, right now, we have like more than 7,500 deep sky objects, includes almost all the messier except one or two, M45 and M20, and most of the NGCs, they can be seen through a telescope. It will require a 12 or 14-inch telescopes to see. Okay, that's enough theory. And so what to do, we need to start observing. We will address the question now. So how do we see? Naked eyes are best, and you don't need to invest anything, but then you need to go to a very rural areas or dark sky areas and watch how the sky, the deep sky object, and binoculars are very good. We found we have here a star party, and then the binoculars are, I find this is the best thing through which you can see all the messier object or NGC object, whatever is visible. And small telescope are even better, and large telescopes are more preferred, but then large telescope carrying it to a rural area or finding a large telescope is will be very difficult. So this is like an example of naked sky observation. From here on the left side, it is a city sky, you cannot see anything except the stars. And while a rural area, you can see the tiny blob on the right side, which is more oval shape that you can easily make it. For example, here in the very dark sky, when there is no moon, you can easily make out Andromeda galaxy from Hanley, from a place like Hanley. So this is how a binocular vision will be in a city. It will be totally, the contrast may not be there, which is on the left side. And whereas in a very rural skies like Hanley, you can easily make out the fuzzy patch through a binocular observations, or this is a similar for telescope observations, and how the light pollution makes the difference in identifying the two object. So this is a Orion Nebula as seen from a light pollution to light polluted city, or from a rural. So getting started in this, we will get started with some observation techniques and fact. So one of the best thing about how to observe is that dark sky adaptation. So the eye is a wonderful, it's a very wonderful instrument. It has got very high dynamic range, so we can easily control the aperture. So this is the iris actually. As you go into the darkness, your eyes will dilate. That means the pupil will become bigger, aperture of the eyes we can, and you can easily see much better. But in the essence, eyes regulate the amount of light entering it by controlling the size of the entrance aperture. So sudden darkness, what does the eye do when we walk into a dark place? The pupil does that, begins to dilate, but this is not immediate, it takes time. So that's why we call the dark sky adaptation. So if you go immediately from a very light polluted thing, or even your room which is like, which has light pollution, if you go outside you won't be able to see it. But then the more you stay outside and inside the dark and get adapted with it, and then your pupil will dilate and you can see it much better. So walk into a room, dark room, with from a well lit room, and see how it takes time for an object to start appearing to you. So this is called the, so if you're there are many techniques. So if you are want to adapt it well, you can close your eyes, being in a dark sky, and then you can for at least 5 minutes, and then suddenly open, then you can see how the stars, many stars appear. Obviously it has to be like out of the city, because it cannot be used in a city light. Okay. So it can make a very good adaptation. And there will be many people who will be using the finder charts or even mobile to see what they are trying to observe. So we always have to use dim red lights to do that. And even your mobile, there are some settings where you can use dimmer lights and red fonts, which can be used and not disturb the others. So sky maps can be used nowadays. People, there are a lot of apps called the Stellarium, the night sky chart, etc., that can be used. So the sky maps are the maps of the sky. And we have, well, when you're observing, there are like geographical thing. We call the longitude in the sky as the right ascension, and the latitude are replaced by declination. It is just like the latitude and longitude locate point, and in the sky it is the RAW to locate a point in the sky. So you get so it's very technical, but then you can slowly learn about it, how to use a map. So there are like constellation. They are basically, constellation is nothing, it's just an imaginary group of nearby stars, are called they are made by ancients who are associated with the stars. They just use it, many people use it to associate the stars so that they can easily identify them. It was used, and so why should we bother about them? And there are some imaginary, because but then the constellation help us remaining stars and organize them. So it becomes easy and to refer to the stars. We can mentally divide the sky into constellation, and it makes things more organized. For example, like in the early in the morning nowadays, we can just see, oh, the Scorpius is rising, so that means we can see Antares and lots of Rio, Q, so we can see all of them. So that's how it's making us easy to identify the stars associated with them. And they make the sky easier to understand and map. So first identify the major constellation mentally, and know which constellation neighbor which ones. Well, and probably everyone must have heard about the zodiac, the constellation around the earth, around those constellation through which the sun appears to pass around the year. Okay, so in winter you can like Orion is the easiest constellation to identify. You can start from there. You can hop on to other plates, to Taurus, and any other stars that you want. If it is in winter, in the Orion is almost there throughout the night. So around October, no, October it will rise, and right now in March it is setting. So in the winter, Orion you can use all the time. And here in Orion, you can also notice that the Betelgeuse is red in color. Fine. So this is the Orion Nebula, as you must have seen, and you must have heard the interesting event with the Betelgeuse. It periodically it dims and becomes bright, and we are told that it can become a supernova anytime because it's a very old star and it's in the dying stage. So this is the Orion. And so obviously how to use your chart and how to use your east and west, that you may have to slowly learn, because the sky chart are always designed so that it can be used holding it over your head. So many times it can be inverted, but then you can slowly use, and you can use your eyes very effectively. All See, ultimately most of the observation will be done through, even if you are doing deep sky astrophotography also, first then you will have to know where the constellation is. So if you would have learned to use eyes effectively, you can find the fainter object more easily. So because we have already talked about dark sky adaptation, and naked eye observation is the most beautiful thing. I've seen many people doing that, and they enjoy it like anything. So first prepare yourself for naked eye observation, and then you can slowly identify the different stars, star pattern estimism and constellation. Proceed to a dark sky, but first you should learn it very well, and go to a dark sky site before sunset. Wait for sunset, and there are like many things other than the one. So there is this winter Milky Way. So the winter Milky Way appears as a band of thin glow. So many people have this conception when they see the core of the Milky Way. They think that is the Milky Way, but then Milky Way, and people always have the assumption it comes only in summer, but Milky Way is comes on also in winter. That's the spiral arms. So there are a lot of beautiful places, things to show in I will show you in the another image that I've taken, where winter Milky Way and what all we can see. Okay, so and also zodiacal light. This as the sunset, the sky becomes darker and darker. Then after some time, when there is still a hint of twilight around, we may see a conical beam of light starting from a place where the sun set and going all the way up to the zenith. If your dark sky is really dark, so this is called the zodiacal light. So you must be wondering what zodiacal light is. I will just show you. It is the scattered light from the sun. It runs along the zodiacal belt, or the constellation, zodiac constellation. So this is an image I took very recently in January 10th. So here you can see on the left side is the zodiacal light, the bright glow, which is just like a triangular shape over the hill. I don't know why I'm not able to move my mouse here. Maybe because the recording are happening or something like that. So here you can see on your left side of the image near the two tripods and above the hill, that's the zodiacal light. And on the right side of most of the image, you can see this is the winter Milky Way arm, and this is beautiful. And you can see just above the car on the right side, just above that is the Jupiter at its opposition. That means when it was the nearest and it was appearing as the biggest, that was on there. And here you can see the Orion just on the right side of the Jupiter is the Orion constellation. And you can see many just above the Orion constellation, you can see the Taurus and the Pleiades. And similarly, you can see the Andromeda galaxy, which is just on the center top, and it's just like an spiral galaxy. It can be seen so through a dark sky. This is actually a 360-degree by 180-degree panorama of the whole sky. So it contains the whole sky 360 degrees. So here you can see the whatever was visible on that night, it was totally, so it was taken at Chilingzhou, which is just near Hanle, and it was frozen. And here on in the foreground you can see a lot of ice cracks. Um, and I had three camera setup, and I was using one to capture all this, and one was doing something, and the third was unused. So Andromeda, as I showed you the Andromeda galaxy, so in the winter months you can easily see the Andromeda very beautifully. And you will notice something fuzzy when M31 is printed in all the sky chart. So this is our nearest large neighboring galaxy. It's 2.2 million light years away. So and the summer Milky Way looks like a thick fog of a dark rift. This core of the Milky Way, the galactic center, lies in the Sagittarius. That's the summer which include is thus very thick. See, this is an image of the core of the Milky Way above the Himalayan Chandra telescope. And the two bright star on the left side of the screen is the brighter one is Jupiter, and the fainter one is Saturn. And you can see the Milky Way core here. And this is the summer, and you can see a lot of things. So this is the one of the image I earlier showed. So this is the whole Milky Way arm in summer. Okay. And here like conservation and preservation, this seems to stop after sunset. Nobody wants to bother about it or say anything about the word conservation. But then definitely, as we have seen, as I will show you in the subsequent slide, is that there are like a lot of light pollution happening. And they're like our ancestors or even your uncles, your parents, they might have seen the sky very nicely when they were young, but now you can't see anything. So how does light pollution affect us? So you can see this image that I have taken, and this is a monastery in Ladakh, and here you can see it is fully lighted, and you can see the Ursa Major just above the monastery. And here at this time I knew that 11 o'clock, the time we used to have some light curtain, but 11 o'clock the light will go, so you can subsequently see the changes. And many people think that more light is good, and but then it is something which is annoying our eyes, and not just, and it is getting wasted up in the skies, and not uh, we are not utilizing it very well. So okay, and you can see the subsequent slide when I knew that the light will go off, and you can see how beautiful the monastery looks without the lights, and also the stars along with it. So how light of pollution effect on the night sky. Here again, this is an satellite image of the light pollution in the night sky. And you can easily see where India is, and most of the places, uh, two-third of, obviously I can say some 70-80% of the population cannot see Milky Way from there. And this is a zoomed up image of the Milky of India. And here you can see the red is Delhi is more polluted. Even the cities like Bangalore, Hyderabad, and they are quite light. And the blacks are where there is no light pollution or very less light pollution. So Ladakh just falls on the top, right? And there are some places like Ladakh, Himachal, and some places which are very inside the dense forest, which are actually dark. Otherwise, we have actually lighted up the whole country, which is also bad too. So here you can see, as zoomed out, here you can see Jammu and Kashmir, and this is where Ladakh is. And the two elliptical thing you can see in this just above Kashmir, IR, is Leh and one of its suburbs. So Leh is also competing with the rest of India in terms of light pollution. So, and you can see Delhi is heavily light polluted, and most of the cities like Chandigarh, Punjab, some cities in Punjab. Okay. And how can we curb light pollution? Actually, on the right side, you can see a beautiful example where you can how to use the light. So you can see the first image where the street lamp is, it's actually totally wasted up into the sky. Second, uh, the street lamp, you can see it is little bit there is shade up there. Third one, you can see the light they're going. And fourth one is the best example, because it is where you are using where you want it, actually, not like throwing up or wasting it. And here you, in this case, you can see some visible night sky also. So a very how very quality comprehensive light management needs to be adopted all over. And we should encourage the use of outdoors light only where necessary. As you told Govindaji, and because you are in Nagpur, I heard there's a very beautiful initiative in Nagpur where they switch off the unnecessary street lamps also after 11. That's a beautiful example which can be followed all over the all over India also. And we need to use curtains on windows and use low light beams by vehicles moving at night. And this is an example of recess light done well and done. So you can see two example of a petrol pump. And if you are doing the lighting well on the bottom, you can see everything clearly. But on the top, you can see there are a lot of light glares, etc. And so there are a lot of animals. It has light pollution of harmful, and there are classical cases where they have seen for reptiles and many birds where they tend to get attracted towards light, thinking that it is a moonlight, and in the process causing a lot of harms. And as you know, a lot of there are animals uh, which actually they sleep in the night so that they can do good they can uh, because it interferes with their migration, mating, foraging for food and sleep. If they don't get proper sleep, then they may not be able to get their prey very well. So these are all animals and plants live by the rhythm based on 24-hour cycle. So wildlife can become disoriented by too much artificial light at night. So these are an example. So here you can see this street lamp is also trespassing inside your rooms also, which is totally bad. And you won't get proper, it disturbs your sleep patterns. So now new research is being done to discover the impact of on our biological clock. Because since ancestor we have been always our ancestors at the time when there's no light, they used to sleep when it's dark, and then they used to be awake and work when there is lighted up. But now everybody has forgotten that people are glued to TV, have lights all over them, and even for them, the Netflix and YouTube, that even evening time in the lot of studies which have, and that has shown that there are a lot of cancer which can be, obesity can be done, and lot of cancer can be caused by the white light when we are sleeping with white lights on. Then so what we also follow here, like the our when we sleep, it should be completely dark. So our sleep wake pattern is governed by the day and night cycle. Nighttime exposure to artificial light suppresses melatonin production, which is very if because if melatonin production is more, then obviously uh, is we won't be able to take proper rest, and obviously the capabilities of fighting the diseases will be less. So our bodies produce hormone melatonin in response to circadian rhythm. Melatonin keeps us healthy. It is an or antioxidant properties, induces sleeps, boosts the immune system, lower cholesterol, helps in functioning of thyroid, pancreas, ovaries, testes, and adrenal. So brighter does not mean safer also. It's like more light does not make us safer. Rather, it gives a false sense of security. In fact, improper shielding can actually cause shadows, allowing perpetrators to take advantage of hiding spots which we cannot you cannot see. So there are a lot of studies being made, and it has found that the street lights don't prevent accident but do cost lots of money. So glare in hours due to bright headlights can be binding and reduce our night vision. So this is an example. I hope I'm not over the time. It's fine. So there are like this is an example of a campus. There you can see in the middle there's a student and lighting. So the glaring lamp you can see here. So in the next image, the boy is still in the image, but you won't be able to see him. So this is one of the reason for light, because a bright light can cause very good so we see whatever is lighted by the light but not in the shadow. So here you can see under the lamppost the boy is there, but you won't be able to see. So this is like something, if your light is not well lit wherever and whenever you want it, wherever you want it, so it can be used for criminal activities also. So what can we do is like we should shield our lights, use timer and motion sensors, use lower wattage bulbs, save electricity, CO2 emissions, use warm color bulbs like yellow and amber instead of white. It feels better, sleeps better, and be healthier. And most importantly, appreciate and enjoy the night sky, teach and share with others. And thank you very much for this opportunity. And this is a selfie at Hanle. You can see many stars there. And I stop here.
Well, thank you very much. As expected, it has been an inspiring and enlightening session this evening. You have covered so many things in a lucid way that this entire lecture can now be shared as a curiosity class with anyone sitting at home. And yes, one of the outcomes I would see that the information that you have shared about light pollution. Sir, we will definitely work on this through our Citizen Science Series initiative. It is important to take this information to a general people. And yes, Science Exploratory will definitely take the initiative for Nagpur City. So may I
Okay.
now request students for their questions if they have any. Omkar Vaidya is there in the room, Zoom room, would like to ask some questions. Students, you can also text your questions in the chat box. Right, let me unmute you.
Thank you very much.
Right, you can raise your hands and you can ask your questions one by one. Now you can unmute yourself and ask.
Sir, am I audible?
Yes.
Yes,
Yeah.
yes.
Sir, I wanted to ask that after finding all
Tell,
the constellations in the
tell
sky,
your name, tell your name and which class you are studying, right?
uh, I
Turn on
am
your camera also so that sir can see you and
Yeah,
then
yeah,
ask
he's
your
listening.
question, right?
Sir, I am Omkar Vaidya from class 6th. I am asking that after finding all the constellations, what object should I look for?
No, yeah, that's see, these are something there are so many objects and so many different as I was telling about all the galaxy. If you want to see how an other galaxy looks, and how a double star looks, or what is like a gas nebula or an. So these are like how many different things that you can, which are there in the skies, and which can be a visual treat for them, for you. And obviously we will always said that night sky, we learn a lot while seeing, getting educated, getting more knowledge from the night sky.
Thank you, sir.
Thank you.
Yes, anyone else? You can text your questions in the chat box, or you can raise your hands. Manan has raised his hand. Manan, you can ask your question.
Sir, my name is Manan Atre and I study in class 8th. My question is that you said that you were exploring the sky in Ladakh, but people say that it is better to sky, better to go deeper into the sky when you are on a mountain because it's closer to the sky and it gets clearer as there is no light pollution. So is this true?
This is very much true, and yeah, this is a very nice question. Obviously, we see the
Will be
observatories
good
from.
if you can unshare your screen so that you will be in full view.
Okay, I thought if somebody wants to see it, okay. So, uh,
Okay,
yeah, we'll just okay, stop share. Okay, yeah.
fine, fine.
So Manan, when I was standing, like we are at 4,500 meters above sea level, though. So practically like half the atmosphere. If you consider Everest where there's no oxygen, so we are at 4,500, like nearly half the Everest. So we are on a plateau. We like, obviously our the observatory is on a hillock and it is surrounded by higher hills, but then uh, if if you go higher, it will be more difficult in terms of the uh, work we do, because there is less oxygen. And also you are very right, because when we go higher, obviously there will be less atmosphere and there will be less attenuation of the starlight. What I mean is, like, when the starlight comes to you, if you are in a city, it gets attenuated by all the particles, like the aerosol or even the humidity, and you get less light. While as if you are in a Ladakh, like I am at Hanle in Ladakh, so like we get more stars. So it is like this. If you are able to see 5 to 7 stars or planets at your place, and you know few constellation, and if you come to Ladakh, you will be it will be difficult to identify the known constellation which you know, because there are like thousands of stars in front of you. Okay, I hope it answers your question, Manan.
Yes, sir. Thank you, sir.
Thank you.
Yes, Neha has raised her hand. Neha, you can unmute and you can ask your question.
Yes, sir. Good evening, sir. I am Neha Datte and I'm in class 8. And you said that we do not see the same picture it uh, as we see it in on our computers. So, how
Yeah,
much time does it take, or how much data does it take to make that photo?
correct. Good. See, you know that our eyes flicker, and it flickers even in 1 second, like it flickers many times. So we are not able to grab all the light that is coming from the stars, or even from constellations, or even from deep sky objects. So what happens when you are using a camera? You are gathering the light for 1 hour, 2 hour, 3 hours. So that means you are gathering more lights from the star. So that is how a deep sky object, if you go to a NASA site, any site, when they show pretty images, but then it's like they have combined many images, stacked it, and make it such that all the signal to noise ratio is low, and they have extracted all the beautiful colors out of it. And as I told earlier also, like our eyes cannot decipher, our eyes cannot resolve color in night. But as well as a camera, because they are made up of RGB, so it can collect all the information and you can see a better picture. And obviously for getting more, you need a tracker where you track the, which is actually tracker is just to compensate the night's or earth rotation. So if you have a tracker which compensate to the earth rotation, and you keep tracking to particular and keep imaging it, the star or the constellation, whatever you're trying to image, then you get more data and it is processed and then shown to you. Whereas whenever we are seeing, like when it flickers, we only see momentarily, although they are, our dynamic range is high, but then we don't have that what do you call, it's called the long exposure, which our eyes lacks. Okay. Okay, there are two questions I can read. One from Arna
Yes.
Joshi on the chat. Sir, so the question everybody said that like bright light is harmful. Like it is harmful for our eyes, but can, yes, but can that light harm our other body parts also? What, see, there are two three things to be. White light travels very because it's a higher wavelength than a yellow light. It travels, white or blue travels to a longer distance, so you can see a bright light from a longer distance, so obviously it will travel large distance. While as what happens when you sleep with a white light, so what happens, the body does not get rest, so it's not able to produce the melatonin which is needed. And when you are doing the circadian rhythm well, that means you are sleeping in total darkness, your body gets adequate rest, and the melatonin production is very well, and that suppresses all the, so your body will obviously get harmed when you are sleeping in white lights. So that's why bright light, why bright white light is very very harmful. And I think that might have answered. And there's the second question. There are there are some Omkar has already replied. If we can use Stellarium app on laptop, that's a very good app, you should use it. It's a free app, and it's on laptop, desktop, wherever you want, you can use it. Even the app is very good in mobile. Okay. So Savarda has a good afternoon. What are the some affordable telescope to purchase? Also, if not to purchase a telescope is affordable, and these are, yeah, this monocular is also good. And if you have some something for you, see what is that, like, see, your studies can keep on going, but like a hobby is what makes your life interesting. So if you have astronomy as a hobby and you want to purchase a telescope, there are many telescopes. Like an 8-inch telescope go to can cost, go to not go to manual telescope can, that's the highest range I will suggest here, but then it can go to lakhs also. Something like 40-45,000 go to telescope can come, so that can be the highest. Or you can buy a smaller binoculars also, which are with some mounting, and they are very very good. And obviously you can go for it. It can come between like 10 to maybe around 5 to 25,000, etc. So the mobile apps for it's a Stellarium. I will always, I use Stellarium, but there are other Sky Charts, Sky Maps, etc. But I've used Stellarium and I like it. I'm not, I don't get any money from that, but then that's what I use and I like it very much.
I think questions are over. There is one more question in the chat box, and this will be the last question of the evening. Sir, please read that.
As you said, that sky watching is mountains better. So why don't we do it? As I told you, the higher you go, the atmospheric pressure becomes less. So where I am, the atmospheric pressure is only 600 millibar. So like, so that means like oxygen level is also like very less. So we can just put a telescope on Mount Everest, but then it needs electricity, it needs a lot of things to make it work. And then obviously it will it's you can get better view from it, but the operational point of view is very very difficult on Mount Everest. So there are other, you must have heard about Hubble Space Telescope, James Webb. They're gone into the space, and they can do much better. But in the end, the thing will always come operational, how much expenditure you want, one time investment you want to do. So that is the main criteria. So how constellation help in direction? Constellation is just like how we see the stars. Like if you want to see, if you want to image a new star, or if there is a comet, they will tell you it is in this constellation. So for example, Orion constellation, or in even Taurus, or even Scorpio constellation, Leo constellation. So there will be many charts that will refer to the constellation, and from there you can find where this new comet can be seen, or for example, or even the other or even asteroid, or even some star is brightening or dimming, or there is a supernova explosion. So that's how constellation, it's just an imaginary thing in the sky, and that helps in knowing the sky better.
Yes. Well, thank you very much, sir. On behalf of everyone present here, I
Thank you.
extend our heartfelt gratitude to you for sharing your valuable time, experiences, and insights with us.
Thank you.
Your journey from working at one of the world's highest observatories to capturing the beauty of the night sky has truly fascinated and motivated all of us. Your words have not only deepened our understanding of astronomy, but have also sparked curiosity and wonder among our students. We are especially grateful for the way you made such a vast and complex subject so engaging and relatable in such a short time. Thank you once again, sir, for inspiring our young minds to look up, ask questions, and dream beyond the stars. Soon we would like to see you here in Nagpur. We'll invite you for on some occasion as per your convenience. So with these words, I would like to conclude this session and looking forward to meet you in person. Thank you very much.
Thank you. Thank you very much.